Today's lesson is on the extreme value theorem and critical points. So, starting out, extreme value theorem, it's pretty simple. It's just that if you've got a function f, and if it's continuous on closed interval a to b, then that means it has at least one min and at least one max. So, a minimum point and a maximum point, those are extrema. So that's why we were talking about extreme values. So the absolute highest point or the absolute lowest point. Now I assume in pre-calc you would have learned absolute extreme, absolute max, absolute min, and then relative max and relative min. So just some vocabulary that goes with that. The absolute values, absolute max, absolute min, those are called global extrema. And then the relative max and min are called local extrema. Okay, going to sketch a point. I'm going to just get my endpoints on there, and then I'm just going to kind of sketch a curve here. Okay, so on this interval, so we've got these endpoints from A to B, we're going to have the very top point, that's your absolute max. And the very bottom point is your absolute min. And then we've got this would be a relative max and a relative min. And then on a closed interval, these endpoints can also be extrema. Neither of those are the absolute max or min, but this could be a relative extrema. Okay, so a critical point is simply a point where extrema could happen. So the idea is if you have a function and I say we need to find the critical points, you're going to calculate where extrema could happen. So how do we know where extrema could happen? So if you just think about a graph, something like this. So what is happening at the extrema? So at this maximum point here, what is the slope? It's 0. Point here, it's 0. So a tangent line where the slope is 0, or that is not differentiable, so the derivative does not exist. So we can calculate critical points by setting derivatives equal to 0, or understanding when derivatives do not exist. But this is what we're going to do in today's lesson. So it's very similar to Unit 4 when we were calculating when is the particle at rest. We were looking at when is the velocity equal to 0. So it's essentially the same math, it's just different vocabulary that goes with it. Okay, so first one, if I have f of x equals x squared times x minus 3, and our goal is to find where are the critical points. So first thing I'm going to do is just, before I take derivative, let's just rewrite this. Instead of trying to do the product rule, we can just distribute this to x to the third minus 3x squared, and then we can do the power rule for the derivative. So the derivative is 3x squared minus 6x, and we want to know when is the derivative equal to 0. So now let's factor out a 3x. And then set them equal to 0. So I'll have that x equals 0 and x equals 2. Now, so this is just answering where are the critical points. They happen at x values. And then what are the critical points? You could always plug these back in to your function. So at x equals 0, the y value would be 0, and at x equals 2, the y value would be -4. So just wording, this would be the critical point of -4 is at 2. So y value versus x value. Okay, one more example. Let's look at the function x squared times the natural log of x. Our goal is to find where are the critical points. So let's take the derivative. So let's do product rule. 2x times ln x plus x squared times 1 over x. And I can simplify that. 2x ln x plus just x. And then I'm setting this equal to 0 and solving for x. So I have two terms that both have an x. So I'm going to factor an x out in front. Okay, so here I've got x equals 0, and here I have 2 ln x plus 1 equals 0. So let's see, solving a logarithmic equation, I'm going to subtract 1 and divide by 2. So natural log of x equals -1/2. And then convert it to its exponential form, so it's base e to the power of -1/2 equals x. So here is one of the solutions, and then this one is actually not in the domain because on the original function, the natural log, you cannot take natural log of 0. That does not exist. So there is your full video on global versus local extrema, the extreme value theorem, and finding where critical points are. Good luck with your lesson.